Hi everyone. So the purpose of this video is to understand displacement. The learning targets are to recall the definition of displacement, compare and contrast displacement and distance, execute calculations for displacement, and interpret position time graphs. In this video, I'll introduce you to all those concepts, and then after the video, you'll have to do some practice problems where you practice using some of these concepts. Let's start with the definition of displacement. So displacement is a change in position of an object. You might wonder, how is that different from distance? Like, why do we have to make a fancy word up for displacement? But it's not the same as distance. Distance is the total length of the actual path taken by the object. So let's look at this picture over here. Let's look at these red lines. Let's imagine that a person's getting home from school and they have to follow the roads when they are driving home. So it's 3 kilometers on this road, and then 2, and then 3, and then 1, 1, 1. You can see that this person has to drive a certain distance to get home. But how far is it really from their school to their home? Well, it says it's only 5 kilometers. So that 5 kilometers in this example is the displacement. It's just the difference between the initial position, where you started, and the final position, where you ended. In physics, we use the international system. So in that example, you might have seen kilometers, or km. For a lot of the problems that you'll see in my class, you'll see meters, or just m, to measure displacement and distance. For those of you who are wondering, a meter is a little bit longer than a yard. So for anyone who's more familiar with the English system, yard is a little bit shorter than a meter. Let's just do an example for some of you who are sports people like I am, and I'm sure some of you can be playing for the football team or are a fan of the football team. Let's think about a football player, and let's say they have to, they're going to run the ball. Let's say they start at the 40-yard line. That's like what we call the line of scrimmage. And let's say they start over here, but then they run this way, they juke somebody, they run towards the sideline, and they run down the sideline, and then they dodge a few more players, and then they get into the end zone. That's great. How far did they actually go? Anyone who's a football fan knows that if the line of scrimmage was the 40-yard line, and you went all the way to the end zone, we would call that a 60-yard touchdown run. 60 yards. Now, their path was much different than that. I mean, this path is kind of all crazy and curvy. I mean, they could have really ran for 90 yards, for all we know. But the actual displacement is 60 yards. And that's the number that we care about in physics. Oftentimes, the number that we really care about is the displacement. So that's just an example for some of you who are familiar with American football. All right, another way to kind of think about this is to use a number line. It's kind of like a football field has those numbers. You can use a number line like this to kind of look at how far does a person actually go. So let's take this example of a person walks 5 meters to the right. What is their displacement? Well, you can draw an arrow. I mean, it's kind of simple to draw, but we have an arrow for this person going from here all the way over to here. And let's say they stop right here at 5 meters. Okay, well, we know that they've gone 5 meters, and then this is where they would end up right here. So their displacement would be 5 meters. So we write it like that. Now, one thing I'll just point out real quick is that it said to the right, and so we ended up with a positive number. You'll notice over here that some of these numbers are negative. Anything to the left is negative, and anything to the right is positive. So it's very similar to like a math graph that you might see in a math class, where left is negative and right is positive. Let's look at maybe a more tricky problem where we have to keep track of positives and negatives. So a person walks 5 meters to the right and then 7 meters to the left. What is their displacement? Some of you paying attention might notice that this is the same question as the pretest. So let's draw some arrows. So we'll go 5 to the right, and that's positive, but then 7 to the left would be considered negative. So I'll go 7 all the way over here. So notice what I did was I drew my 5, and then right where my my first arrow stops, that's where I put my second arrow. And I drew a second arrow like this all the way over here. All right, these arrows are called vectors, and a vector is just a way to kind of show which direction is something moving and how far, like what is the magnitude of the number. So we can see that we ended up over here at -2 meters. And so we would say that their displacement is -2 meters. Again, that negative just means that we are to the left of where we started. We had to actually move to the left to get to this final position. So we can use number lines to help us kind of think about motion that's left and right. And we can also use these arrows called vectors. And some of you might recognize this person from Despicable Me called Vector. And he talks about how he commits crimes with both direction and magnitude. And it's usually represented by an arrow. That's a term that we'll use a lot in physics to kind of help us think about which direction is something moving and how far did it go. All right, so here's another example. And this is a work example that I'll have you put in your notes. So a person starts at 5 meters, walks 9 meters to the left, then 6 meters to the right. Their final position is 2 meters. What is their displacement? We can draw some arrows just like we did before. I'm going to show you a little trick here in a minute that makes this problem more straightforward. All right, first thing that was a little bit tricky about this question. We're starting at 5 meters. We're not starting at 0, and that might throw some people off. But just like the football example, and just like many other examples in real life, we don't always start at this position of 0. Right? In football, you don't always start at the goal line. You have different places where the ball might be down the field. There's many places where your position might not be what we call 0. So in this case, we're starting at what we would call 5. And they're going to walk 9 meters to the left. So we have to go all the way over here, and that would be 9. And then I'm going to draw another arrow for my 6 meters to the right. So 1, 2, 3, 4, 5, 6. And just like the problem says, my final position is right here at 2 meters. Okay, that's my final position. But how far did I actually go? Well, I went from 5 and I ended up at 2. So what is that? Well, the difference between these two numbers is 3. But I went to the left, so I would have to say -3. -3 meters. So one way to think about this is my initial position was 5, and my final position was 2. So what I could do is I could take my final position of 2, and I can subtract it from my initial position. So 2 minus 5 is -3. That's exactly what I got for my displacement. So this is an easy way to figure out your displacement. You have to know your initial position, your final position minus your initial position. And sometimes what we'll do is position is sometimes marked with an X. All right, and we use X, kind of like X marks the spot. So we would call this XF for final. We would call this XI for initial. And then what we would actually get is what we would call our change in position, what we call our displacement. And so what we would draw is a little triangle here. All right. So a triangle is a way to kind of represent a change. And that triangle is a Greek letter called delta. So anytime you hear delta, it really means like a change. I don't want to list everything. All right. So here's the equation that you definitely want to have in your notes. Delta x, or displacement, is equal to final position minus initial position. Okay, here's the last thing we'll look at. This is a position time graph. Again, something that you saw in your pretest. And let's look at an example of what this position time graph is showing. So time is down here on the x-axis, and position is on the y-axis. And you can see this is 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. And this is in seconds. 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. All right, so let's just look at an example. What is the object's position at time equals 2 seconds? Well, what I would do is I would find 2 seconds right here, and then I would look at, okay, at 2 seconds, I'm right here. My line is right here. And so going across, that would be 2. So the position is 2 meters. That's my position at time equals 2. All right, here's the next one. How far has the object moved from time equals 1 to time equals 5? Well, at time equals 1, let's see, at time equals 1, I'm at 1. And at time equals 5, I have to go up here, right here, and go across. My position is 5. So my final position, let me try to write this down. My final position is 5. My initial position is 1. So using the equation that we just saw, my displacement is going to be my final position minus my initial position. So final minus initial. Sorry, my writing isn't so good with the pen. But this would be 5, and this would be 1. And so my displacement would therefore equal 4. And that would be my final answer. So my displacement would be 4 meters. All right, so this was an introduction to many different concepts. You'll have to use these concepts on some practice problems, and then you'll have to show me that you've mastered these concepts on a mastery check. So good luck.